In this video, we will look at how to perform centrality analysis in Mobius. There are two functions for calculating centrality. The analyze.Degree function is for calculating degree centrality. The analyze.Centrality function is for calculating betweenness, closeness, and harmonic centrality. The image shows a randomly generated street grid which we will use for experimenting with measuring different types of centralities. The analysis functions all return dictionaries of data. The analyze.Centrality function returns a dictionary containing two lists. The posis key is a list of positions, and the centrality key is a list of centrality values, one for each position. The two lists are equal in length and aligned, so that the values in each list are related. The data returned by analyze.Degree function differs, depending on whether the network is undirected or directed. In both cases, the dictionary will have a posis key, which is a list of positions. If the network is directed, the dictionary will have one additional list. The list is the degree centrality values, which can be retrieved using the degree key. The image shows the data for an undirected network. If the network is undirected, the dictionary will have two additional lists. The first list is the degree centrality values for incoming edges, which can be retrieved using the in-degree key. The second list is the degree centrality values for outgoing edges, which can be retrieved using the out-degree key. Both centrality functions normalize centrality values. This means that the values will always be in the range between 0 and 1. As with the data returned by the shortest path function, centrality values can be visualized in various ways. The images show three different ways of visualizing the same centrality values. In the top image, edges are extruded. In the middle image, positions are extruded. And in the bottom image, columns are generated. The centrality functions only return values for centralities at positions. So for the top image, the centrality of each edge is calculated by taking the average of the centralities for the two positions. Next we will look at the different centrality metrics that can be calculated. The analyze.Degree function has four parameters. The first two parameters are the positions where to calculate centrality and the entities that define the network. If the positions are set to null, then centralities for all positions in the network will be calculated. The third parameter is the alpha value, which will be explained in the next slide. The fourth parameter allows you to set whether the network should be treated as directed or undirected. The results returned can be attached to the geometric entities as attribute data. In the example code, the degree centrality values are attached to the positions. The alpha value controls how degree centrality is calculated. If alpha is 0, then degree centrality is calculated by counting edges. This is shown in the top image. If alpha is 1, the degree centrality is calculated by summing the edge weights. This is shown in the bottom image. For any values between 0 and 1, then the two approaches are combined. For the analyze.Centrality function, the first two parameters are the same. They are the positions where to calculate centrality and the entities that define the network. In this case, there is no alpha parameter. The third parameter allows you to set directed or undirected. And the fourth parameter allows you to select betweenness, closeness, and harmonic centrality. In the example code, the centrality values are attached to the positions. The images show the results from performing a centrality analysis on the same network, using the three metrics: betweenness, closeness, and harmonic centrality. As can be seen from the images, each metric highlights different parts of the network.